Okay, so I'm going to show you something up here on the screen. Watch it front. Okay, a little video for us to look at. Okay, so we got the stairs workout was the first one on the left, and then we have the super stairs workout on the right. Okay, all right, now let's talk about the difference between, what do you guys notice about the difference between the stairs exercise and the super stairs exercise? Just somebody raise a hand. Just what do you notice? Go ahead, Brady.
Stairs, you go straight up, straight down.
Okay, all right. He goes straight up and he goes straight down, and then the difference with the super stairs?
You go up one, down one, stair, up two, down two.
Okay. Okay, all right. Now it's hard for you guys to tell from here, but there are 21 steps or 21 stairs that he goes up, right? So could we figure out how many stairs he does, like how many steps he takes to do the whole stairs exercise? How many steps does he take? You know, like a little athletic tracker, something that track your steps for the day. So if he was doing the stairs one, and I know that there's 21 stairs in that flight, how many steps is he taking? 42, right? Because he's going up 21 and he's coming down 21, right? But then we've got the super stairs set. He's obviously going to be taking more steps, right? Because he's going up and down and then up and then down and then up and then down and then up and then down. So why don't you tell your neighbor, like, just let's ballpark it. Just take a guess. How many steps do you think he's going to take? Just take a guess at it. How many steps do you think he's going to take? If he took 42 steps to go up and down, take a guess. Don't do any math. Just take a guess. Just estimate it. How many do you think he's going to go? Okay, how many? For the super stairs. How many steps do you think he's going to take for super stairs? Just don't try to calculate it. Don't try to figure it out. Just take a guess. Just take a guess. Okay, all right, that's a guess. Perfect. Okay, 200. Okay, so we got 200. What'd you say again? 42,200. Okay, all right, somebody else. Give me another guess. Brody, what do you got? 415? 450? Okay, all right. Okay. How much? 141? 667? Is that what you said? Okay, all right. So here's what we're going to do. We're going to take a look at how these two little exercises here relate to our idea of arithmetic sequences, and what can we mathematically come up with as we're working on these questions. So let's jump to our notes here. Okay, and then we're going to start off by titling our note lesson here. So we're going to call this Lesson 8. And this is, ooh, my little writing didn't work there. All right, Lesson 8, this is Sum of Arithmetic Sequences. The sum of arithmetic sequences for Lesson 8. And our goal, let's just kind of write down a goal here for this lesson. So our goal is to use algebra to find the sum of a certain number, sorry, not plural, singular, certain number of term values in an arithmetic sequence. Okay, so our goal is to use algebra to find the sum of a certain number of term values in an arithmetic sequence. So we're going to now kind of focus our vision a little bit more in this next section, right? So like we started talking about functions in general, then we started talking about sequences. We looked at two different types of Mustangs. We looked at the arithmetic Mustang. We looked at the geometric Mustang. We kind of studied the two different patterns of these functions because I told you that they were cars that are our Mustangs. These are functional relationships. And we looked at these two different things and we kind of, studied these sequences and the ideas of common differences and ratios. Now, we're going to focus our efforts on one car. Okay, we'll look at the geometric one a little bit later in this class, but right now we're going to turn our attention to the arithmetic one. Okay, and so we're going to dig a little bit deeper on this one type of Mustang, this one type of function. Okay, so let's leave ourselves a little bit of room, maybe skip a couple of lines here, and then what I want you to do is just create a nice straight line along here like this. And then up top here, the first thing I'm going to write is superstairs. And then down here, I'm going to write steps. And then I'm going to make some divisions here to work with on my little table of values. We'll start with 1, 2, 3, 4. We'll start with enough to jot down some information here for 5 places. Okay, so now we're going to focus on the superstairs exercise, where he goes up 1 and down 1 and up 2 and down 2 and up 3 and down 3 like that. Okay, all right. So let's jot down the number. We'll call one step, up and down, up and down. We'll call that a superstair. Okay, so if he has 1 superstair, how many steps does he take for 1 superstair? 2 steps, good, right? Because he goes up and he goes down. If he does 2 superstairs, he comes down, okay, up 2, down 2, so that's 4. If he does 3 superstairs, okay. If he does 4 superstairs, 8, okay, all right. Are you seeing a pattern in the number of steps? What do you see? Okay, so it looks like that as the term number increases by 1, as the step numbers increase by 1, we're getting a term value that increases by 2, increases by 2, increases by 2. So what do we have here then? We have an arithmetic sequence, right? We have an arithmetic sequence. Okay, now, let's do this. If he takes 5, if he does 5 superstairs, how many steps is he going to take? 10. Okay, so now, here's what the question was to you, right? I asked you to estimate how many steps you thought he would take over the course of the whole exercise, right? So let's take and let's consider 5 superstairs. So 5 superstairs, the whole exercise. So that means he starts with 1, and then he does 2, and then does 3, and then he does 4, and then he does 5. How many steps does he take? Well, if he does 1, he takes 2 steps. And then if he does, then he goes back down and he comes up and does 2 superstairs. He comes back down. So then he takes another 4 steps. And then he goes to the 3rd level. And so he takes 6 steps. You see what I'm doing? 1 superstair, 2 superstair, 3 superstair, 4 superstair. We're counting how many steps he takes, 5 superstairs. That's what we saw in the video, was 5 sets of superstairs. So I'm going to go 2, and then I'm going to add to that 4 steps, and then I'm going to add to that 6 steps, and then I'm going to do what? Add to that 8 steps, and then add to that 10 steps, and that's 5 superstairs, right? Okay, so how many total steps did he take? Yeah, 6 plus 6 is 12, plus 8 is 20, plus 10 is 30. So to do the 5 super steps, the 5 superstairs that we saw him do in the video, where he goes up and down and up and down and up and down and up and down, and he does that up to the 5th step, he took a total of 30 steps. Okay? Now, I'm going to give you some vocabulary that you may see, just so that you're aware of. I want you to kind of underline this and then shoot a little arrow over here. Okay? When we want to talk about the sum of the terms of a sequence, this would be the math problem that I would write out. If I were to talk about this here, I would say, what is the sum of the first 5 terms, like that. I would say the sum of the first 5 terms of the sequence. You would tell me, well, it's 30 because I added up the values of the sequence for the first 5 terms. Does that make sense? So that's what a sum of terms is. And if I asked you to write out a sum of terms, you would write out 2 plus 4 plus 6 plus 8 plus 10 equals 30. That's how you would show your work for that. Okay? All right. So he takes 30 total steps. All right. Now, why don't you write out a sum of terms and come up with a calculation for me for 8 superstair sets. So if he goes and he does 8 instead of 5, what's he going to get? I want you to write out the sum of terms and come up with the solution of total number of steps for me. Go ahead. All right. Did you get a total of 72 steps to complete 8 superstairs? Yes. Up and down and up and down and up and down and up and down. So if he goes up to the 8th step, comes down, he's done a total of 72 steps up and down the stairs. Okay, we good so far? Okay, now, let's consider, we're going to do a little study here. Let's consider 8 superstairs for our little study here. We just did this, okay? So what I want you to do down below here, skip a line, and I want you to leave a little space, and we're going to write out the number of steps that he takes, and we're going to leave a little space in between them. So I'm going to go 2, and then I'm going to go 4, and then I'm going to go 6, and then 8, 10, 12, 14, and 16. Okay, now, how many superstairs are we looking at? How many are we considering? 8. Okay, all right. So then let's just put a little note over here. So the total terms we're looking at are 8. Everybody good there? Total terms we're looking at are 8. Okay, so now if we think of this sort of geometrically or like as a median, we can find sort of a middle space, and we can think, well, that middle sort of is right here. 4 terms on one side, 4 terms on the other side. And I can actually take these terms and consider them together. Like, for example, what if I took these 2 terms and I added them up? What would I get? Okay, so if I added those 2 terms up, they would equal 18. What if I took these 2 terms here and added them up? Those would equal 18. Wait, what's going on here? If I take these 2 terms here and add them up, what do we get? 18. I'll show you. Okay. So when I take these 2 terms and add them up, what do we get? Okay, so there's something going on here, huh? Yeah. Right? When I'm partnering these, their distance from the median, when they have an equal distance from the median, they sum to the same value. Okay, well then, what if I paired them up? What if I thought of them in groups like I have them kind of marked out with my highlighter here? So if I was originally considering 8 total terms, how many pairs of terms would I be working with? Okay, so in this case, I would be working with 4 pairs of terms, and I now know that each pair sums up to the value of 18 for this particular example, right? So really what I'm saying is I've got 4 groups of 18. Okay, all right, now watch this. I could write this using some algebraic notation like this. I could say the sum, capital S, of the first 8 terms of this sequence is equal to 4 groups of 18. What's 4 times 18? 7. Okay, 72. So that works, right? Okay. Where did the 4 come from? Okay, where did the pairs come from? The 8 terms. So we took the total number of terms that we wanted to sum up, and we cut it in half because we paired them up. So really, I could maybe it would be better. I could write it like that. Okay. All right. Yeah. We'll get there. It's a good question, but we'll get there. Okay, but we're going to take the total number of terms and we're going to pair them up, right? We're going to divide them by 2. Okay? Where did the 18 come from? Yeah, the sum of each pair, right? And there's a lot of different options that we could use there, right? But one thing that we've seen that's consistent in all of our sequences is that we've got a first term and a last term in our sequence. And since we know that all these pairs add up to 18, we could rewrite this inside one a little bit differently. We could say, if I took the first term of my sequence and I added it to the last term of my sequence, I would get the value I need, right? So I'm just kind of reframing this in terms of some different math problems. Okay, so then let's consider, what if we wanted to find super stairs? Could you take this and write it here with variables so that I could find any sum of terms? Why don't you try to do it? See, give it a shot. You got pencils, you're writing in pencils. You can always erase it if you don't get it right. Give it a shot. See if you figure it out. Good, jot it down, see what you come up with. Give it a try. If you're moving in the right direction, you should have started here. Did you get here? Did you get that? Yeah. Right? The sum of number of terms. Well, wait, that's the same as the number of terms we divided by 2, isn't it? Right? It was like the sum of 8 terms. We took the 8 and divided by 2. So then could I say this? Oh, okay. All right. Okay. Well, now I just need a way to say the first term and the last term. How could I generically say the first term? Okay, how about a sub 1? Sure, that means first term, right? And I want to add to that the last term. Nice, Lauren, way to go. A sub n, exactly. All right, here you go, ladies and gentlemen. This is called your sum formula. This is your sum formula. I see what you did there. That's great, man. This is sum formula. All right, yes, ma'am. No, the 2 won't change because what we did was we took our number of terms and paired them up. And pairs are always 2s. So that part won't change. But the number of terms will change. Okay, all right. Now, listen, we got 10 minutes, so we need to move quick because I want to do one example with you. All right, and then you're going to have 6 examples for homework to do. So let's switch to formative because I have an example on formative for you to do right now. Okay, leave your notes out if you want. Okay. Okay, so you should be looking at this question right here. I'm going to go to the show your work section, so I would encourage you to open up the show your work section. All right, now we're going to use the following sequence from the super stairs example that shows the first 4 terms, which are the total steps, right? So 2 up and then 4 and then 6 and then 8, right? And it also shows the 21st term. So to do 21 like if you did the 21st super stair set, it's up 21 and down 21, right? So that's 42. We already talked about that, right? That's the 21st super stair set. It's up 21 and down 21. Now the question that we want to do is figure out how many total steps does he take to do the entire exercise from the first one all the way to the 21st one, every single one moving up the track, right? Okay, so we know that this is an arithmetic sequence. Let's jot down our sum formula that we were working with for this particular problem. This time, though, we're going to write it like this, okay? Watch me. So how many terms are we trying to figure out the sum of here? 21. Okay, so we're going to go sum of the first 21 terms is equal to the number of terms divided by 2 And then what we want is we want the first term and the last term added together, right? So what's the first term? Okay, and what's the last term? Okay, 42. All right, now watch this. This right here is what I want you to type into number 1. Okay, see how it says, enter the sum formula as an equation that is used to find the sum of the first 21 terms of the sequence. That's how you're going to structure your answer for number 1 and for the rest of the problems that you do for your homework. So the first one, you're going to do like this. The sum of the first 21 terms is 21 divided by 2, and then in parentheses, the first term plus the last term. Okay, go ahead and type that in. You should get a point when you type that in. Yes, it has to be a capital S. Thank you. Yes. It needs to be a capital S. So now we're here, right? Okay, so now let's see if we can calculate it. So now I'm going to go, so the sum of the first 21 terms is, now watch this. Because this is not a whole number, like works out really nice, I'm just going to leave this like this for right now. And then I'm going to add up these two numbers here. So 2 plus 42 is going to give me 44, right? Okay, now you can do this however you want. You can divide, and then you can multiply, and then you can divide. Whatever works best for you, right? You can put this over 1, and you could cross-cancel and make that 22, and then you can multiply. So when you calculate out the sum of the first 21 terms, what do you come up with? 462. And so that's how you're going to type in your answer for the second one. Enter the sum as an equation that is translated. The sum of the first 21 terms is equal to, or is, 462. Okay, did that work for you? Yeah. Okay, all right. For this.
Wait, I was high-key close.
462 superstar. Okay? All right. So that's what we're starting with today. That's part 1. Part 1 is I'm going to give you some sequence terms, and then I'm going to give you the last term of the sequence, and I'm going to tell you what term number that is, and your job is going to be to calculate the sum of the first 12 terms, 17 terms, 24 terms, 9 terms, 13 terms, whatever it is that I give you of that last term number. You're going to calculate those. So your work should look like what it looked like on our paper, right? I'm not going to go back up there, but it should look like what we did on our paper, writing your workout, and then typing your answer in as those sum formulas and equations. Questions? You got it? Yeah. All right, good. That's part 1 for what we're doing, and then part 2 we'll pick up on tomorrow.